In this problem, I'll be adding two-digit integers. In my first number, 82, I have an 8 in the tens place, and I will represent that using blocks by using 8 rods. In fact, I'll just use a straight line to represent a rod. Remember that each rod is equal to 10 units. Now that I've drawn 8 rods, notice there's a 2 in the ones place, so I need 2 units. I would just use dots to represent units, so I have 2 units. Then add to this the number 98, which has 9 in the tens place, which means you'd have 9 rods. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then since there's 8 in the ones place, I will draw 8 more units. 1, 2, 3, 4, 5, 6, 7, 8. Because these numbers have the same sign, take the absolute value of the numbers, but the absolute value of a positive number is itself, so the 82 would not change and the 98 would not change. So then you add them together and keep the common sign of the numbers, and the common sign to both of them is positive. So I will get a positive result by adding the number of rods and units together. However, because I have 10 units, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I'm going to exchange these 10 units, so I'm going to circle this and say those go away, and exchange them for 1 rod, because 10 units is equal to 1 rod. I took away the 10 units, I'm going to add 1 more rod. Now I'm going to count the number of rods, and because I have more than 10 rods, I'm going to have to change 10 rods into what's called a flat. So it turns out that 10 rods have 100 units, and we'll be using a flat to represent 100 units. And a flat basically can be drawn by just using a square. So let me count 10 rods and exchange it for a flat. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if I take these 10 rods, circling them means they're no longer there, and I'm going to change it to a flat. So let's put this over here. Now I have a flat, which is 100, so I'm going to put a 1 in the hundreds place of my answer. And then now I need to count the number of rods I have left over. 1, 2, 3, 4, 5, 6, 7, 8. I have 8 rods, which means there's 8 in the tens place. I have no units left because I exchanged all 10 of these for a rod, so there's 0 in the units place. So this tells me that 82 plus 98 is equal to 180, and I know it's positive because the rule is to keep the common sign of the numbers when the signs are the same, and both numbers have a positive sign, so my answer has a positive sign. Now to represent this with an algorithm, suppose we took 82 and lined it up with 98. The plus goes over here. We typically start in the ones column and add. 8 plus 2 is 10, and this is like having the 10 units over here that we took and exchanged it for 1 rod. So what we do is when we exchange the 10 units for a rod, there were no units left, so there's be a 0 in the ones place, but we exchanged it for 1 rod, so we'll put a 1 in the tens place here to represent that we gained 1 rod in addition to the 8 that we had here and the 9 rods originally here. Now we took 10 of the rods and exchanged it for a flat, which gave us 100. You can think of that as the 9 and the 1 makes 10, and 10 rods makes 100, and then you'd have an 8 in the tens place left over. The other way to think about it is if you added 9 plus 1, you'd get 10, and if you took 10 and added 8, you'd get 18. Either way that you think about it, you end up with an 8 in the tens place, just as before, representing the 8 rods, and a 1 in the hundreds place that was represented by the flat. Here is another example where the two numbers I'm adding together have the same sign. So the first step is to take the absolute values of the numbers and then add them. The absolute value of negative 53 is positive 53. the absolute value of negative 64 is positive 64. So I am to add these, and at the very end we'll keep the common sign of the original numbers, which in this case is negative. So I'm going to add 53 and 64, but I'm going to start representing my number with blocks. So I notice that the number 53 has a 5 in the tens place. That would give me 5 rods. 1, 2, 3, 4, 5. I have 3 in the ones place, which gives me 3 units. 1, 2, 3. Then I'm to add 64, which has a 6 in the tens place, which would give me 6 rods. 1, 2, 3, 4, 5, 6. A 4 in the ones place would add on 4 more units. If you want to start with units, 1, 2, 3, 4, 5, 6, 7, I have 7 units here in the ones place. Now to count my rods, it turns out I have more than 10 rods, so I'm going to have to change 10 of the rods into what's called a flat. Each rod is made up of 10 units, and a flat is made up of 10 rods. So let me count 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These 10 rods I can exchange. You can think of them as I'm giving them away and exchanging them for one flat. And one flat represents 100 units, or it represents 10 rods. Now that I made this exchange, and I've already done the 7 units, going to the tens place of my number, notice I have 1 rod giving me a 1 in the tens place. I have 1 flat giving me a 1 in the hundreds place. This gives me 117. Don't forget at the end that you're supposed to keep the sign on the original numbers that they had in common. They both were negative, so my final answer will be negative 117. I'm going to now represent the addition using an algorithm, meaning the addition of 53 and 64. I'm going to start in the ones place, adding the 4 and the 3, like we added the 4 units here and the 3 units here. When we added them together, we ended up with 7. Remember I said that we had more than 10 rods, so I needed to make an exchange. 6 plus 5 turns out to be more than 10. In fact, if you take 6 and add 5, you get 11. You can write the 11 down, or you could think of it as 6 plus 5 is 11, putting a 1 in the tens place. Normally you would carry the 1 over, and if you did so, 1 would be adding to 0, which would still leave you 1. In either case, you get 117. Don't forget the rule says that you keep the common sign of the numbers before you took the absolute values. The common sign was negative, so my final answer would be negative 117.